Dear students, in this video we are going to discuss about how to perform deformation and stress analysis in a cantilever beam which is subjected to uniformly distributed load, that is UDL and point load, using ANSYS APDL software. Okay, so this is the given problem which is taken from a standard textbook. So the load values are given in pounds and the distance as mentioned feet unit. So simply we can convert this problem into SI units. So 100 cross 100 cross section mm square, then the UDL with 0.1623 Newton per mm, and the point load value of magnitude 3558.58 Newton in the negative y-axis direction. Okay, then the distances in millimeter have been noted. So now we can model this problem and solve the problem using ANSYS APDL. Okay, so for that first we have to select the type of problem, structural, then preprocessor element type, add beam element to node 188, then material properties, material models, structural, linear, elastic, isotropic, by assuming the material of the given beam element as steel, the known Young's modulus value of the steel to be feet here to 10 power 5 Newton per mm square. Then sections, beam, common sections, breadth and height values of the beam should be presented here. So in ANSYS APDL, actually the breadth value should be feet as height value and height value to be feet as breadth value. Okay. Modeling, create using key points and lines. So in active CS, first reference point can be taken as 0, 0, 0, the first, that is leftmost key point. Okay, and the second key point is, so from the left end, the second point can be fixed at the point at which the loading condition is given. So the distance is 4267.2 minus 3657.6. So this position, so 609.6. Along the x-axis direction only the beam is getting distributed. So the remaining coordinate positions will be kept as 0. So now the third nodal position is 4267.2 millimeter. So the key points have been generated. Now using lines option, straight line, we can connect the modeled key points. Okay. So now to follow the finite element modeling procedure, we have to subdivide the entire structure into convenient elements, and after which we have to mesh them. Okay, to consider as a whole element. So mesh tool, lines, set, select the lines which have been generated. Okay, take the number of elements as 100, say. Okay, now the entire structure has been subdivided into 100 number of elements. Now we have to mesh them again. So mesh, select the subdivided entire elements. Okay, now the entire element has been meshed. Now go to solution to define the constraint and loading condition. So define loads, apply structural displacement on key points. Okay, so the rightmost point has been constrained in all the directions. So arrest the key point, rightmost key point. Then to apply the point load on key points. So this point is loaded with a magnitude of minus 3558.58 Newton. Okay, then to apply the uniformly distributed load, we have to go to pressure option on beams. Okay, select the beam using box option. Okay, for applying the uniformly distributed in the negative y-axis direction, select the load key as enter the load key as 2, then in both I and jth nodal points uniformly distributed load is acting. So we can give the value of uniformly distributed load for the ith position only. The value is 0.1623 Newton per mm. Okay, now we can solve the problem. Current load setup. Okay, the solution is done. To read the deformation and stress results, first we have to go to general post processor, plot results, contour plot, nodal solution, DOF solution, displacement vector sum. Okay, the maximum deformation experienced by the cantilever beam for the given loading condition is 47.5842 millimeter. To read the stress induced results, go to element table, define table. With the aid of sequence number, we can define the stress results for bending stress on beam. So add the sequence number for bending stress value as SMI SC32 for the ith node, and by sequence number SMI SC37 for the jth node. Okay. So now then again go to plot results, line element results, ith node set SMI SC32, and for the jth node set SMI SC37. So this is the stress induced plot, which shows the maximum stress induced bending stress value 86.4947 megapascal at the fixed position of the given cantilever beam. So this